Welcome guys. Last lecture we have discussed about the concept of continuum microscopic and macroscopic approach. So in continuation to that, from the syllabus we are going to discuss about path function, point function, intensive extensive property and total and specific quantity. Let's go on. So first of all, what is property of system? Property is actually characteristic of a system. So whenever we are going to analyze any things, we need to understand the behavior of certain things. So behavior we can understand by its property. So properties such as its pressure, temperature, volume, and mass. For example, for a human body or a human being, we call that how much height, how much centimeter height, what skin tone he is, what weight he has, he or she has. So everything will be given. I mean that is called the property of a system. So similarly, in thermodynamic analysis, we'll be discussing on the various properties such as pressure, temperature, volume, mass, internal energy, enthalpy, heat energy, work energy, everything. We call that as property. Here we have two types of property. One is intensive property and extensive property, and specific and total property. So intensive properties are properties those independent of mass. So properties which are all independent of mass are called intensive property. And the examples of intensive property are temperature, pressure, density. And extensive property or those it's contrary to the intensive type of properties where it is dependent of mass. So extensive properties are quantities that depends on mass of the system. So examples of extensive property is heat energy, work energy, volume, mass, everything is dependent of mass. So I can give you an example. If you consider two cases. One, you have a matchstick in your hand. Another case, you have 1 kg of coal. If you try to burn both things, the amount of heat liberated will be more for what case? Either in case 1 or case 2. Yes, of course, the amount of heat energy in burning 1 kg of fuel is larger. So, and heat energy is an extensive property since it depends on the quantity of substance which you are going to burn. So, mass. So you consider a thing, I mean, in a container where these properties are there. When we split this box, the mass will be shared equal, the volume will be shared equal, the temperature, pressure, density doesn't vary. For example, if you have a water at a large container, what will be the density of the water? Yes, it's 1000 kg per meter cube. When we take one glass of water from when we take one glass of water from the vessel and if you try to measure the density of the water in the glass, it will be always equal to the density which is on the container. So it says that even though the mass varies, the density doesn't vary. So density is an intensive property. Next is path function and point function. As the name says, functions are the properties. So the properties which depends on point of the system in a PV diagram. We'll call that as point function, and properties which depends on path of the system we call that as path function. For example, if you try to move from one point to other point, the shortest distance is straight line, and if you wish to go to the same point from moving a longer distance, so whenever the distance traveled is shorter, then the less amount of energy we spend. If we go more, I mean, if you try to work for longer distance, then the amount of work energy spent is more. So work and energies are path function. It doesn't depend upon point function. So point function or properties where depends upon the initial and final state. So the properties which does not depends on path of the process is called point function. Example: pressure, temperature, internal energy, entropy, enthalpy, etc. And path function are the quantities or properties. These quantities we don't call that as properties because heat energy, work energy, those energies can be quantified. We don't call that as property. That those are not constant values. These are all quantities. So those quantities will vary on the path of the process. So of course we'll get a better idea or understanding when progress on the unit 1 because when we solve problems for various other various process we'll get different value for heat transfer. That shows that heat energy or work energy is depends on path of the process. And one more thing is the cyclic integral of point function is 0 and cyclic because internal energy is a point function and cyclic integral of path function is not equal to 0. It's one of a point you have to understand. Thank you.